Thank you everyone for joining us for this webinar, the new episode of Simvia Insider. Today we will talk about mesh interoperability with Mariam, which is the product owner of Meshlane, the Python package that she will present in a few minutes. Fatih, which is a developer and testing Meshlane, and Florian, which is a CFD engineer, but he also is a huge fan of Meshlane. So today the agenda is quite simple. First, Florian will talk about what could be done with the same mesh with several solvers. Then Mariam will explain how we try to fork meshio in order to get Meshlane, and then Fatih will present all the features, the new features that we have, and the performance that we try to have with this new package. Just one thing before we really started, you have this Q&A session, so we will try to save 10 minutes in order to answer to all the questions that you have. So do not hesitate to use this Q&A session during the webinar, and we will have 10 minutes at the end of it to answer to this question. So let's get started. Now, Florian, the stage is yours.
Thank you for the introduction, Maxime. So now let me take a few minutes to discuss about the problems that Meshlane solves. So when we want to do a benchmark between solver, when we want to compare some solver between them, it is important to use exactly the same mesh, because if we work with different mesh, we want to know if the different results that we will get will come from the mesh or from the solver. So it is really important to work with the same mesh when we will do a fair benchmark, a fair comparison between solver. So it seems really obvious, but in practice it is not really easy to do, because every solver, FEA solver or CFD solver, has a native mesh format. Typically, Code Saturn, which is the EDF open source CFD solver, require a MED format for the mesh. OpenForm require polymesh, and this Fluent need MSH format. So in practice, it can be complex to do a fair benchmark between Code Saturn, OpenForm, or ANSYS. And moreover, historically, each native format comes from a different mesher. For instance, if you want to generate MSH mesh format, you need to use ICM-CFD or ANSYS meshing now. And consequently, if you want to do a fair benchmark between ANSYS and Code Saturn, it can be complex to generate a MED mesh format with ICM-CFD, because ICM-CFD does not allow to write MED format. And finally, that is the problem that Meshlane solves, because Meshlane allow to convert the variety of mesh format. And moreover, Meshlane allow also to work with a mesher which is not in the ecosystem of the solvers that you will use. So it will be very interesting for you. So now I will let Mariam and Fatih discuss more deeply about Meshlane.
Yes, thank you, Florian. So before we get into detail on Meshlane, we should talk about meshio, which is where Meshlane stems from. So meshio is an open source Python library. It was released under the MIT license, and it was developed and created by Nico Schlomer. So it's a consistent interface where you can read and write over 30 mesh formats. And how it works very briefly, it's that it uses a single unified data model, which is called the mesh object. So when you give it a mesh, it will translate it to this uniform format, which is the med object. Like if we can see here that let's say I have a med mesh. So if I write meshio info to get a few additional info about this mesh, meshio will output the mesh object of this mesh. So we will see the number of points, cells, and which types of cells exactly. So it really works very easily. It's just a command line. You type meshio convert and then your input mesh and the output mesh. And so here I tested a VTK conversion. And then if I do a meshio info to the converted mesh file, I can see that the mesh object has exactly the same elements as the original mesh. So this is a quick verification to make sure that no data was lost or cells were lost. Of course, we can do more thorough verifications, but this is just a quick way to ensure that the conversion happened successfully. So now I will give you a quick timeline about meshio. So the first public release happened in 2015 by Nico Schlemmer. So it was the first release on PyP. It contained a few supported formats. And then 3 years later, it was the V2, which introduced the meshed object that I talked to you about in the last slide. And then a few years later, there was the V3 and V4, which and this period consisted in rapid releases and performance improvements, as well as redesigned cell data structure. So now in 2021, it was the last major line of meshio, which is the V5. So it consisted of a linear core and refined CLI. So earlier I showed you convert and info commands, but you can also compress, decompress, and also convert from ASCII to binary via the CLI directly. And in early 2024, it was the last release of meshio. So since then, the project have stalled and it appeared to be no longer maintained. So this brings us to Meshlane. So why did we at Simvia fork meshio and how we landed on Meshlane? So the first thing is that it really started from our internal needs. So like Florian described in the beginning, we constantly juggle between different softwares and different mesh formats. So in our workflows, we noticed that we really needed a tool like this. So meshio was the obvious choice. So when we started using it, we noticed that there was many formats that weren't supported. And even if some of the conversions happened successfully, we realized that the output format used a very old version of this mesh format. For example, MED, it used a very old format, so we needed to do a few updates in meshio. So we did a fork internally to try to implement our developments to make our workflows work. And then we noticed that meshio had a really big community, and that that issues and PRs were a bit piling up. So, but we also noticed that till now we have hundreds of thousands of downloads on PyP per month for meshio. So we decided that our internal fork has to be a community commitment. So we now maintain actively Meshlane, and we have committed people and time to keep this project alive. So we started a few developments that Fatih will present to you, and your contributions and feedbacks are very much welcome.
Thank you, Mariam. So now that we know why we are working on Meshlane and how important it is for us as well as for the community, I'm gonna walk you through all the new feature we have done at Simvia, starting with the med module because as we know in Simvia we use a lot of Salome and Codaster, and the med module is the format that we initially start with. So to match the requirements of Salome and Codaster, we did a version upgrade from Med 3 to Med 4.1. And also talking with other people, we realized that once we have a med file that has multiple meshes, meshio will crash, as we can see in the picture of the terminal, and will just tell us that the med file should contain only one mesh, which is not very practical for industrial uses or any uses generally. So we did a huge improvement around that, and now Meshlane today can successfully read and write several meshes in only one file. And also, we can get med files not only from Salome and Codaster, but also from GMSH. But we will face structural differences inside of the file, which made Meshio back then have a lot of problems conserving data. So we did a development around this that will allow us that allows us today with Meshlane to have a better understanding and reading of our med files, regardless of the expression solver. And we did a huge work around 3D cell orientation as well, and now Meshlane can support a new mesh types that are polyhedrals and polygons. Also, during our work, we realized that we have a need for new formats, and the two big modules that we have released are the ANSYS ENP and OpenFOAM. So for the ANSYS ENP, now with Meshlane, you can convert your .enp and your .cdb files and read them to any form, and convert them to any format, and also read them and explore them. And with OpenFOAM, now today you can successfully convert them to any format of the Meshlane supported format. And considering the CLI, we did a conversion progress, which consists on a verbosity showing which step of the conversion we're at. So you don't have to worry about is it working or not. In the CLI, you can see that the work is in progress, and in the terminal it will tell you when it's done. And also we added a useful warning, and the most important one was around duplicate cells, because some solvers will eventually crash or not accept your files because you have duplicate cells. So with Meshlane today, you can know this beforehand, and you can also have a function that will allow you to remove the duplicates and just through the terminal. So I'm gonna walk you through some of the tests around our new developments, starting with the med files and the multi-meshes. So in the video, what I do first is I convert with meshio a file that has multiple meshes, and we can see that it doesn't work, but with Meshlane it does indeed work. And now what I'm gonna do is that I'm gonna open it on Salome. So the first file is the original one. We can see that we have two meshes. The first one is called boundary, and the other one is called fluid domain, that has multiple groups. And now I will open the converted file, and we can see that the names were conserved, but not only that, also the groups were conserved, and we can visualize the meshes in both cases. And if we want to thoroughly verify that everything is the same, now I opened the mesh informations for both the original and the converted file, and we can see that everything pretty much stays the same, that we are indeed in a 4.1 med version. And yeah, same for the second one. When we both open both of them, we can see that everything stays the same. And we are indeed in the 4.1 version. All right. So the same, I did the same work with the env.cdb file. So with an internal env file that we had, I converted it to MED. We also can see the CLI functions I talked to you about earlier. So we can see that it's read-in, it's write-in, and once it's done, it tells you it's done. So, and now I'm printing the informations around of the converted file, and we can see that the number of points and the number of cells matches what we have on the screenshot from the original env file. And now I'll open it on Salome, and we can see that it's successfully opened, and we can visualize the same mesh. And our groups, the contact and true, everything pretty much stays the same as in the original file. And we did the same thing with OpenFOAM. So here we convert OpenFOAM file to .med. The CLE works for every module, so you don't have to worry about that. Now we're visualizing both the .foam and the .med file, and we can see that the structure stays pretty much the same. And also, if I extrude and to see the boundary conditions for both my original input file and for my converted file, we can see that everything stays the same, and we didn't lose anything regarding the mesh nor the boundary condition, and the structure pretty much stays the same. So now that we run the test on single file, our work has been done on a much larger database, and primarily with the med module, because it's the module where we have a very, very large database, starting from Codaster database, from our internal med files, and also from handmade med files with our Salome solver. And what we tested was the read-in and the integrity of the file. We made sure that if we do a round trip from med to med, or from any format to med, the file must stay readable. The structure must stay valid. We should not be seeing any degenerated cells or any data that stays inconsistent, and that everything is preserved bit to bit after write-in and during the read-in. And for this test to be as general and as valid as possible, we not only tested a large database, but we made sure to test different types of meshes, from triangle to quad to hexahedron to quadratic element, linear elements, and also a different size of files, from really, really small files with only a few nodes to close to 1 million nodes. And we did the same test on other modules, primarily the ones we added, like the ANSYS ENP, the OpenFOAM, but also Abacus ENP, because we had some internal needs for that. And that made us discover that, for example, the Abacus module was very, very complex. The algorithm was very complex, which made it crash for files that had over 200K nodes. So we did a refactoring of the code to make it go to a less complexity. And for the other files, we ran a lot of tests to make sure that read-in integrity round trip is good. But since we don't have access to these solvers, if you have any issues with your file, we'll be gladly happy to solve them with you and to run more tests. But your help is needed, and I thank you beforehand. So now that I walked you through the new features and the tests we've done, I'm gonna let Mariam take you through the roadmap of Meshlane.
Yes, thank you very much, Lati. So to tell you our plan for the upcoming weeks for Meshlane. So we need to do a few corrections and compatibility. The first one, which was highly requested as well from the community, is to do a NumPy upgrade, because right now, since we forked it from meshio, and as I explained earlier, we just started a few developments to be able to convert the meshes that we needed. We didn't really pay attention to upgrading the NumPy version, but this is definitely on the map, and we will try to do it quickly, because it's now a version that is no longer supported. So of course this one will also come with a Python upgrade. For the moment, we haven't really assessed on which NumPy2 version we will implement, but it's something that we will assess and we will be releasing soon. The second thing we want to implement is that Meshlane can convert a mesh format from another, but we also would like to implement a versioning conversion. So, like, for example, sometimes when we do coupling between codes, sometimes a solver requires a med version that is equal to 4.1 and another one a med version that is equal to 5, for example. So we want to implement a versioning converter, and we will begin with med, but of course this can be extended to other formats. We also want to implement a full CGNS reader and writer, because right now it's a bit limited in a way that, for example, if you give it a CGNS with more than one zone, it cannot really handle it well. It is also currently very strict about the node names for these CGNS files. So this is definitely something we want to work on, especially for CFD conversions, because these CGNS is a very used format in CFD. So as we also presented that we did add a OpenFOAM reader. So right now, Meshlane can read a OpenFOAM polymesh mesh and convert it to another format, but this operation is not reversible, which means that you cannot have a CGNS or a MED and convert it to an OpenFOAM polymesh. So this is something we also want to implement, and it was requested by a user, as well as we also want to add other formats like the OVM. And of course, we are very, very open to the community. If we see that there is a request for a new format, we will very gladly look into it. So now, if we talk about the robustness and reach, also for the roadmap. So we will keep on working on performance and memory improvements. So if work on this was done for ANSYS ENP, for example, but we still have some formats that we can very much improve in terms of time of reading and converting. So this is something that we have on the radar. And we also want to do continuous solver validation. So right now, how we verify that the conversion happened well, because sometimes Meshlane would successfully generate a MED and we can successfully visualize it, but then when you give it to a solver, whether it's a FEA or a CFD, sometimes these solvers have very strict criteria. So what we want to do is that we want to add a continuous testing, maybe in a CI. We haven't really assessed on how we are going to implement this, but is that every mesh that Meshlane produces, we want to verify that it is well read by the solvers. Another thing is that we want to add a sanity check. Maybe you can call it Meshlane check or Meshlane doctor, which is a diagnostic CLI that would flag any duplicated cells if there are inverted or degenerated cells. So it would just be before you run a conversion, you can do a quick check on your mesh to see if before even converting the initial mesh had a few issues. The last thing I want to mention also is that we will, in the upcoming days, release another repository, which would be called Meshlane Tutorials. So it would be a public repository with many tutorials, benchmarks, examples, scripts, and mesh files in different formats that you can check and see how we use Meshlane and how it can be used. And also we would have meshes with different cell types, and this would be with time we will add many formats and meshes. So so now what we want to say is that the roadmap is also very dependent on you. So do not hesitate to open issues or even PRs if you want to develop in Meshlane. We very much welcome it. Maybe I can show our GitHub repository. So this is our Meshlane repository. So you can don't hesitate to open issues. We've already received a few requests, as I mentioned, like the OpenFOAM writer. And as well as why we use a old NumPy version. So yeah, do not hesitate to create a new issue and tell us your need. What would be optimal is that if you encounter issues with Meshlane, because as I said, we focused first on the met format because it's the one that interested us, but we do not want to stop at this format. So of course we want to improve every format that Meshlane can read and write. So do not hesitate to tell us if you encounter any issues. And optimally, if you join the mesh and that was used, if it's not confidential, and if it is, maybe you can try to reproduce the same issue on another on a smaller mesh. And also do not hesitate to share with us the issue that Meshlane produces. And also do not hesitate to contribute. You have here a few instructions on how you can contribute to Meshlane. So yeah, don't hesitate to suggest your developments and open PRs. And also one thing I want to mention is that we haven't yet added the roadmap markdown on what I presented today, but it will come very, very soon. So that's it for the presentation. Thank you everyone for listening.
Thank you, Fatih. Thank you, Mariam and Florian. So yeah, we have a few minutes to have your question. So the first one is quite obvious. Thank you, Julien. Is about Nico Schlemmer and the roadmap that we have, and the reason why meshio is sleeping. So I will start, and Mariam, you will complete my answer. So yeah, we tried to have some discussion with Nico. Unfortunately, we didn't. He didn't respond to what we said. So of course, the idea of Meshlane is not to do a duplicate of meshio, is to improve what has been done. That's the reason why we try to do things as clean as we can in the open source mind. So first, keep the same version numbering and start from this. And the other thing that Fatih and Mariam have done is the fact that we have a pull request on meshio, which is related to the beginning of Meshlane. So unfortunately, Nico wasn't able to treat this pull request. So yeah, we try to do this. And Mariam, maybe you can add some things about the issue, the one that are in meshio and the link that we try to do with Meshlane.
Yes, there was a few so when we started our fork, the first thing we did is that to parse the issues that were on the meshio repository and try to see which one we can fix. So actually, the first med improvements we did, they come from issues that were opened on meshio, and for these issues we have contacted the authors to tell them that we have implemented a correction for this in Meshlane. So of course, to say that Meshlane, the first improvements and developments, they all stemmed from existing issues in Meshio.
Thank you, Mariam. So the other question from Jose is related to PyVista reader. So maybe Mariam, you had a chance to have a look at this. Just to be clear about Meshio, it's a package that has been used in many software, especially in Salome. So the platform that is developed by EDF and CEA in France. So we are aware of the fact that there are many other software which are related to Meshio, and we will try to have some collaboration with people which are depending on Meshio and see if they want to use Meshlane. But on this specific case, Mariam, do you have any other technical insights to give on PyVista and Meshlane?
We haven't yet tried to couple the PyVista with Meshlane to see if the existing issues that are in Meshio still exist with Meshlane. But it's definitely something we can try to do first. On our part, try to replace Meshio with Meshlane in PyVista, and then see if some functionalities now work. So this is, as Maxime said, it's something we have in mind for the other, not just PyVista, for other solvers or libraries that use Meshio. We will try bit by bit correcting the issues in Meshlane and reach out to the developers to see if they can link Meshlane as well to their products.
Right. Thank you. We have two other questions which are quite related, I think. It's about multi-body mesh and the problems difficulties that we may have with Meshio, and is it okay with Meshlane now? So multi-body for Abacus first, and then ANSYS and OpenFOAM. Maybe Fatih, you can give us more insights on what is Meshlane is capable of.
Can you please repeat the question? Didn't quite hear you.
Yeah, for the multi-body mesh from ENP Abacus, is it something that you are able to handle now with Meshlane?
Normally, I don't see any problem with it. We can convert from med to med with multi-meshes. And from Abacus, I never really asked myself this question, but from my memory, I think Abacus doesn't have any problem reading multi-meshes ENP files. So starting from this point, I think can easily be done and converted to the med format, back and forth.
But just to precise, like I said, sometimes we really need your feedback and example meshes to test. So if this doesn't work yet, do not hesitate to open an issue and to share with us the mesh so we can take a look.
Yes.
Okay, thank you. And the same question for OpenFOAM, the multi-body mesh from OpenFOAM. Is it something that is on the roadmap, Mariam?
Yes, I haven't tested the multi-body with the OpenFOAM. Right now, the OpenFOAM, what we support is polymesh. So I don't think we will encounter issues with this. to be honest, I haven't tested a multi-body OpenFOAM case, but if it's a polymesh, I don't think that there will be any issues to do it. And if there is, you know where to open an issue.
Yes, thank you. The other one is about the .stdl format and the interoperability. It's a format that is involved in meshio and also in Meshlane. So once again, we try to have our attention on the MED format. The only thing that I can say about the STL format is the fact that Salome has a converter and something to import STL format and to clean it before you do your mesh with NetGen or other algorithms which are included in Salome. So if you have some troubles with STL format, obviously do not hesitate to drop an issue in Meshlane, but maybe the answer will be that you can also try to use Salome, which is also open source, if you want to do the cleaning of the geometry and so on. We have many questions. I didn't have the opportunity to select every one of them. So yeah, maybe this one from Franco. Do we want to replace meshio in ParaView with Meshlane? So maybe Mariam, you can give your opinion on this.
Maybe. So to replace it, I think we need to have the approval of the ParaView developers. But however, what we can do is create a plugin, a Meshlane plugin that would be easily downloadable by the community and with clear instructions to how to import it to ParaView. So I know that ParaView has many plugins that you can easily fetch online and link them with ParaView. So this is actually a very good remark that we haven't thought about it yet, but I think we can definitely work on a ParaView plugin and to make it as easy as possible to replace it and to be able to add it to ParaView. And then I think the question to completely replace it, it's not really up to us, but I think we can, definitely work on a ParaView Meshlane plugin.
Okay, and we are really connected with Kitware, so we can try to discuss with them about this. Another question from Charles about is it possible with Meshlane to get access to the element numbering in the MED format, especially if we want to use to do the link with Codaster and Salome Mecha. So just for the element numbering, Fatih, is it something easy to do with Meshlane?
I didn't quite understand the question, to be honest. Do you answer it?
So I know that for now it's not, I don't think it's immediate to get the element numbering directly from Meshlane. However, as I said, we will try to improve as much the CLI, and maybe we can add an option to try to access these info easily. But I think maybe in Salome it might be easier to have a view of the element numbering more easy than just a terminal output maybe.
But there is no built-in awareness in Meshlane for the element numbering, like with the Codaster. Also, I saw like a couple questions regarding ENP files. I just want to share with the community that for the moment, to convert or read an ENP file, you should specify the input format, because I saw like a question for me with the error, and the error is mostly because you didn't specify the input format. So if it's an Abacus file, you just put the command as it is, meshio c or convert your file the format you want, and you just add input file Abacus or input file ANSYS ENP. So we can make sure that Meshlane uses the right module. But this is something on the road roadmap that will very soon not be an issue anymore, and the specification will not be.
Yes, what we try to do is that Meshlane, for some format, it can automatically detect the solver, like for example, MSH, it can detect if it's coming from ANSYS or GMSH. For ENP, it's not yet the case, but it would be. Just for info, this webinar, the slides we presented, there will be a recording that would be uploaded on YouTube. And you can review the slides where Fatih showed the command line to convert ENP to MED, because in this case, we did specify the input format and the output format. So you can just review it and do the same for Abacus. And yeah, if it doesn't work, open an issue.
Yeah, and maybe one last question from Dorothy. What is the maximum size of the largest mesh that you can convert from CGNS to MED if you want to do some fluid dynamics? What is a large mesh for you, Fatih?
Well, to be honest, for me, like the largest file I used was more than 5 million nodes, but not with CGNS. As we said during the presentation, the CGNS module is very weak, and it's something that we have on the roadmap. Like it should be rebuilt from, I guess, from zero. But yeah, with other formats, I think the largest file we use are around 2 million nodes. I even reached 5 million once. But yeah. But it's more than welcome that if you have any large files that are not confidential to open an issue with us, and that will allow us also to improve the performance of Meshlane, because with bigger files we can see if the code needs some refactoring or anything, and yeah, that's very much welcome.
Okay, thank you, Fatih. One last this time, really, from Andres, which is really interesting. That's the reason why I take it. Can I use Meshlane to chain two different solvers, transferring the fields, the result fields, from one to another? How do you handle this with Meshlane, Fatih, or Mariam, maybe?
Yeah, Meshlane can also convert output meshes, so meshes that contain field, and it can also handle transient meshes. So like if you have a mesh result with a field for each time step, this is something that Meshlane can do. But I will precise that we tested this only on MED, but I think the mechanism is implemented in Meshlane, so I don't think that there will be an issue for this.
Okay, thank you, Mariam. Sorry, we have a few more questions, but we will take the time to answer to it, maybe with the descriptions that we will take in the YouTube channel. So the next step for Meshlane will be your issues first, a roadmap that will be clear for every one of you, and if you want to contribute, just feel free. We will also include in the GitHub that we have the tutorials, as Fatih and Mariam mentioned, and we will try in our YouTube channel to put some, let's say, demo of Meshlane, of the usual things that we do at Simvia. And if we want to discuss about this, do not hesitate to open an issue or to contact us by email or by LinkedIn. We'll be more than happy to answer to your question. So once again, thank you, Fatih, Mariam, Florian, and have a nice day, all of you. Bye.
Bye. Thank you.